Okay, hello, my name is Matthew and I'll be completing question 3 today. For part A, the graph contains two parallel edges, E4 and E5. Also, it has a loop at E6 on vertex D. For part B, the adjacency matrix is listed here, with the corresponding endpoints listed and marked according to the graph as a 1. And for the parallel edges, E4 and E5, are marked as 2s. For part C, the adjacency list, which combines the adjacency matrices with the edge list. For each vertex, there is an array of vertices that are adjacent to them. So you can see the edges forming, such as A is adjacent to B and C, B is adjacent to A and C, C is adjacent to A, B and D, and finally D is adjacent to D and C. For part D, the incident matrix, which has the vertices as the rows and the edges as the columns, also as 1s if and only if the vertex is an incident upon the edge. For part E, there isn't any bridges in the graph, as it'd still be a connected graph if you remove any of the edges. And it also doesn't have any cut vertices, as it'd still be a connected graph if you remove one of the vertexes in the graph. And finally, for part F, counting all the edges, 1, 2, 3, 4, 5 and 6, there's 6 in total. The crux of this question really comes down to formulating the visual graph correctly. A lot of information on how the vertices relate to the edges is gleaned just by looking at it. That sums up my solution to question 3. Thank you for watching.